My number 5 says from 1 to 4, integrate u minus 4 over the square root of u. Okay, so since we only can undo two types of derivatives right now, we can undo stuff that we have memorized and we can undo power rule. We can't do anything else. This doesn't look like anything that was memorized. It's not like sine, cosine, it's not a trig function, it's not e to the x, it's not natural log or anything like that. That implies that really you need to figure out how to rewrite this. So I'm assuming that's where you had some issues getting started. Okay, so in a fraction, you can split apart numerators. You can't split apart denominators, but numerators you can. So you could make this u over the square root of u minus 4 over the square root of u. You okay with that? And my 4's and my u's look similar, so I've got to be careful here. I've actually already confused myself. That's a u, that's a u. Okay, and then I still don't really feel ready to integrate, but I would rewrite this. So think about your exponent rules. The square root of u is like u to the 1/2. U to the first is u to the first. And when you divide things that have the same base, that's the same as subtracting their exponents. So just like when you multiply things with the same base, you add the exponents. When you divide things, you subtract the exponents. So 1 minus 1/2 would be 1/2. So all of this from exponent rules becomes just that. Okay, and then over here, this is a 4. So I'm going to think of this as u to the 1/2. And I'm going to move it up to the numerator, which makes it u to the negative 1/2. You okay with both those steps? Okay. Now it's set up in a way that I can undo power rule. Like I can follow what I need to do now. So raise the power by 1, divide by the new power. Dividing by 3 over 2 is the same thing as multiplying by 2 over 3. So I just prefer to do it that way. And then of course check by doing the derivative. Over here, raise the power by 1, divide by the new power, and dividing by 1/2 is the same thing as multiplying by 2. And again, it would be pretty careless to not just test with power rule. Bring this down, lower the power by 1. So you okay with the antiderivative? All right, so now maybe the rest of the question's not easy either, I don't know. But now at least it's just arithmetic. We're going to plug in 4, then plug in 1, subtract, and see what kind of answer we get. So plug in 4. Plug in 1. And then subtract. And see what we end up with in all of this mess. Okay, so dealing with fractional exponents. This is like, oh, this is a 4 by the way. I've got no more u's. These are all 4's now. This is like take 4 to the 3rd power and then square root it. Or take 4 and take the square root and then take that to the 3rd power, whichever order that you want to think of those in. I like to do the square root in this case, because the square root of 4 would be 2. 2 to the 3rd power would be 8. Times that by 2 would be 16. And then times by a 3rd would put it over 3. This is square root, so this would be 2 times 8 would be 16. 1 cubed is still 1. The square root of 1 is still 1, so this is 2/3. Square root of 1 is 1 times 8 would be 8. So I've got 16/3 minus 16. Distribute this to get a minus 2/3 plus 8. These two are both already over 3, so I'm going to go ahead and combine those by adding those fractions. 16 thirds minus 2 thirds would be 14 thirds. Negative 16 plus 8 would be negative 8. Could change 8 into 24 thirds, so they have a common denominator. And finally, 14 thirds minus 24 thirds would be negative 10 thirds. All right, and that's what my answer key says. And then, of course, checking it in the calculator is definitely possible. Actually, it looks like it could have just done this one for us. Again, don't practice doing that because that's not how it's going to be set up for you on our assessment. But if you do check it in the calculator, make sure you put that numerator all in parentheses and then the denominator all in parentheses. So that it does the order of operations the way you're expecting it to. So messy decimal, math enter, change it back to a fraction. I know that's a little small for y'all to see, but it is negative 10 thirds. Okay, so you see where you got stuck on that one? Kind of? Do we? Okay, I might have to look at what you're typing in the calculator then to be sure. You got a question about this one? Yeah. Okay, what is it?
So like on the AP test, will you have to do like you won't be able to use the calculator?
Have to.
Do, like, 4 to 3 halves and stuff.
4 to the 3 halves, yes. You would need to do that without a calculator. Like half the AP test is calculator, half is not. It just kind of depends. Like this wouldn't be the best multiple choice question because it's hard to do in 2 or 3 minutes, even if you know what you're doing. So I would say this type of question could be just like simplified a little bit to test the same skill but not make it quite as long. But yes, you certainly need to be able to do, they will expect you to be able to deal with stuff like this. But again, it's just like, 1 over 2 is like square root. So the square root of 4 is 2, and then deal with the cube. Or do the cube first and then do the square root, whatever you think. It's just, you're doing both. You're raising it to the power and you're square rooting it. So, but yes, they will expect you to be able to do that. The calculator piece, there's sometimes like on FRQs where they give you some very messy integral, and they're not really testing this stuff. They're testing like, do you understand what the integral gives you? What does it mean in context of this problem? And there's times where you could do it by hand, but when you do this, your 15 minutes for your FRQ, you just wasted 5 minutes, and they expected you to use a calculator because they gave you a calculator. So you kind of shoot yourself in the foot by not utilizing your calculator when it's allowed.